Yes, our third micro lecture I'll dedicate to the concepts of aerobic scope and temperature sensitivity, because both concepts are intrinsically ligated to understanding and defining, if you want, the effects of climate change, global warming, on actually animal populations. These are two relatively simple terms to understand, but of course it's also a matter of how do you measure them and what do you do with these results. The first and oldest concept is the concept of Q10, or the temperature sensitivity. Q10 is an indicator of the thermal sensitivity of actually a chemical or a biological process. You could apply a Q10 concept to chemical reactions, that's not our field. We are interested in what happens in biology. And basically the Q10 is the ratio of two processes actually that are measured or that are determined at two different temperatures. Okay, this equation looks very complicated, but if you just listen to me for a second, you'll understand it very clearly. If you measure a given variable at two temperatures that are separated by 10 degrees, the Q10 tells you how much change do you observe between these two temperatures. If we measure metabolic rate at 5 degrees and at 15 degrees, and metabolic rate between 5 and 15 degrees doubles, the Q10 is 2. So the Q10 is the factor by which a given variable changes over a range of 10 degrees centigrades. That's what this expression is giving you. This equation allows you to calculate it even if the temperature difference is not 10 degrees. But the Q10 is the quotient or the change in a given variable when temperature changes 10 degrees. For thermodynamic reasons, and basically that has nothing to do with biology, but with chemistry, the Q10 of most chemical reaction is around 2. That means that when you change temperature by 10 degrees, the rate of reaction of a given equilibrium, chemical equilibrium, basically changes by 2. It doubles. Doubling for every 10 degrees. In biological systems, we have Q10 values. I write here between 1 and 3. That's not uncommon, but it could be much higher than 3 as well. What would a Q10 of 1 indicate? A Q10 of 1 means no change. A Q10 of 1 means no change. The rate at one temperature versus the rate at another temperature 10 degrees different is the same. No change. That's a Q10 of 1. A Q10 of 3 means that instead of doubling, it triples. This is the concept of temperature sensitivity that you have actually expressed in these graphs in here. For example, if oxygen consumption at a given temperature here, 10 degrees, is 76, and at 20 degrees it's 124, the Q10 is 1.6, the division between 124 and 76. And if you go 10 degrees further, 188, then it's 1.5. This would be the Q10 value. You have another calculation here. So the Q10 is a measure of temperature sensitivity, nothing else. Q10 does not have to be 2, but it can be 2. Don't think in deterministic terms. Q10 can actually be any value. And as such, it tells us how sensitive the process is. If Q10 is very high, it means that the change for a 10 degree difference is very large. Therefore, the process is more sensitive. What is aerobic scope? Aerobic scope is the ratio, the quotient between the maximum metabolic rate and the basal or the standard metabolic rate, determined under controlled resting conditions. The ratio between maximum and basal, or maximum and standard. For fish physiologists, for people that work on fish, this is what is called the Fry curve. And you can actually see it here, and that's what I'm going to explain in a second. To obtain the aerobic scope, you need to do measurements on basal metabolic rate, or if in case of fish, you measure standard metabolic rate, and then you measure maximum metabolic rate. That's what's shown in the top graph here. In the x-axis, you have temperature. This is the temperature at which the fish is living. In the y-axis, you have the oxygen consumption. The closed or the black dots here show you the standard metabolic rate. Standard metabolic rate, as expected, increases with temperature. What happens with activity, maximum metabolic rate? It also increases with temperature, but with a different ratio. What is the aerobic scope? The aerobic scope is the ratio, the division between this value and this value, this value and this value, or this value and this value. The aerobic scope tells you how much can an animal increase metabolism from the standard to the maximum. And if you notice, basically the aerobic scope defined in this way basically then increases with the given. Notice that here it's small, it increases, pretty much the same. Here it's maximum, and then it starts decreasing. So typically, these Fry curves over a temperature range give you a peak curve, meaning that there is a point in which you have the optimal aerobic scope, the highest aerobic scope. This is the temperature at which these fish basically can increase metabolism most from the standard metabolism. If you keep increasing temperature more, then the fish can actually do less and less and less, and eventually this will go down to zero. Because this has to do with the costs of basic processes versus the cost of active processes. You have to measure the standard metabolic rate, and you have to measure active metabolic or maximum metabolic rate. How do you do that? Here you have the typical example. This is basically a swimming flume. In this case, what is done is that water, there is a pump that pumps water in this flow meter or in this respirometer against the fish. When the fish is seeing water coming along, the fish basically swims. The more water, the faster the water passes, the faster the fish swims. And this is a closed chamber, therefore you can actually measure how much oxygen is being used by the fish. So that's basically the tools that are used to determine the aerobic scope in the case of fish. You have to measure the standard metabolic rate at the different temperatures, and then you have to measure the maximum metabolic rate at the different temperatures. And this is the curve you get, the typical curve you get when you do these measurements, for example, in trout, for metabolism. What do you get from these performance aerobic scope curves? Well, typically you have actually a point that we call the low critical temperature. This is the point where this animal basically, the lowest temperature that the animal tolerates. And of course there is a highest temperature that is signified, well, the high critical temperature and eventually death. The animal cannot tolerate higher temperatures than this. And then in between you have basically this optimal curve that shows a peak, and basically this is the peak temperature, or this is the temperature at which the aerobic scope is largest. And then you have basically a drop, or what you have a part of the curve in which things go worse. That's what's called the Peju range. The Peju's temperature is the temperature at which a variable turns for worse. In this case, aerobic scope increases until this temperature, but then it goes worse. That's the Peju's range. And that is before you reach the high critical temperature and the temperature at which the animal will die. Why is this relevant? Now we go into our problem. Our physiological problem is to understand how animals are affected by temperature, how animals are affected by global changes in temperature in our planet, global warming. So the idea is that with these basic physiological concepts, can we go in and understand, or try to understand, what are the consequences of increasing temperatures on Earth. And that's what we will see in the next lecture. Thank you very much.